Okay, good evening. This is tutorial for week 10. So this week tutorial, we are going to look at Mohr circle, okay? And I'm going to solve 3 problems, okay? So this problem, you can see is from your homework, question number 6. For the element shown, determine the range of shear xy for which the maximum in plane shearing stress is equal or less than 150 megapascal. Okay. So the information that we are given, so we draw our transformation first. Okay. So we know that this is our x and there is our y, right? So given to us that stress x is equal to minus 20 times 10 to the power 6 Pascal, or I would just write straightly megapascal, and stress y is at minus 120 megapascal, and we are given that the tau max, right, tau max is equal to 150 megapascal, and this tau max that is given, it represents the radius of the circle. So if you look at a solution that has been posted, they come out with a bunch of equations. Okay, let's not do that. Okay, I want to do it by applying Mohr circle. Okay, so I'm going to sketch Mohr circle. Okay, so we have so everything is in compression. Okay, again, this is just a sketch. Okay, then this is our shear. Right, so this is our shearing stress clockwise, anti-clockwise. Okay, and this is our normal stress. So we are given that we have stress x. Okay, so this is our stress x line. Then we are also given that this is our stress y line. Right. So from here we can immediately calculate our stress average or center of the circle. So I'll just do that, center of circle. All right. So your stress average is equal to minus 20 plus by minus 120, and then divided by 2. So this will be equal to minus 20 plus by minus 120 divided by 2 is equal to minus 70 megapascal. So that's our average stress is also the center of our circle. So let me make my life easier by just yeah, I'll just put it closer. Sorry. Okay, so that I'm going to have the center of a circle. So over here, this is our knot. Okay, point O, and we are aware that this is our stress average. Okay, we just calculated it. So given that our hold on, right? So given that our radius is 50 mega. So for example, this is our radius, okay? So we know that our radius, so this is the radius of circle. Again, this is a sketch, okay? Right. So this is the radius of our circle. Okay, so the distance from here to here. Correspond to our radius. Okay. So this correspond to radius of circle. Which is your tau max, right? So we know that our radius of circle which is our tau max, and this is equal to 120 megapascal. No, 150. Sorry. So now to find what we need to find out is we are going to find what is this in shear. Okay, we're going to find this in shear. Right. So this is our shear line. Right. So this is our shear XY line. Right. So when that's the case, you find the shear XY. Will be equal to square root of. So we know that we know that if this is 70 megapascal minus 70 minus 20, right? So this is minus 120, right? So the distance from here to here this distance over here is 50, right? We know that we know the radius of the circle, and this is the distance that we want to find. Oh, sorry. Okay, so this is the distance we're going to find. Okay, so this is equal to 1 radius of circle is 150 squared minus by 70 squared, right? So 150 squared minus 70 squared square root is equal to 132 point, wait, no, 70, what am I talking about? 50, okay. So 150 squared minus 50 squared square root is equal to 141.4. Sorry, 141.421 megapascal. Okay, so your shear value, right? That's the maximum shear axis. So your shear value has to be in the range of plus or minus, okay, 141.421, right? So in the shear, the plus minus means, I mean, it's just a magnitude, the range, okay? So why you ask me why plus or minus? Okay, so we will be within the boundaries of the shear. So over here will be positive 141.421, and here will be minus 141.421. Okay, so I'm going to like quickly sketch our circle. Okay, if you have a compass, you draw immediately. So this is our circle now. Okay, so that's our Mohr circle. Okay, so that's for question. I mean, our the way we solve it is through constructing the circle. If you look at the solution manual, they're using a bunch of equations. In case you don't know how they form the equation, okay, this is how this is done. Okay, right. So that is example number 1. Okay, so we are next. We're going to do question. The next question. Right. So we're going to solve this using Mohr circle. So the two member of uniform cross section 50 millimeters by 80 millimeters are glued along plane AA that forms an angle of 25 degrees from the horizontal. Okay. So knowing that the allowable glue joints are 80 kilopascal and the shear is in 600 kilopascal, determine the largest centric load P that can be applied. Now this question is very not sorry, I wouldn't call it abstract, but you have to have prior knowledge regarding compression and or normal stress and shear stress, which they don't define down here. But I did teach in class, okay? So we know that the normal stress allowable is at 800 kilopascal. And what they don't say, this is in unidirectional, right? This is when they test the strength of the glue, okay, of the joint in just one direction is 800 kilopascal, right? And then the shear allowable is equal to 600 kilopascal. Again, unidirectional. So these two tests are done separately. When they get the normal stress and shear stress, okay, they're not done together. They're not measured together. They're done separately. Okay, but we were not told. Okay, so remember what I say in class: it's easier to do unidirectional than bidirectional. Okay, so from here, let's see what information that we are given. Okay, so we draw our transformation. So this is our x, y. Okay, so we draw our first orientation. Right. So at this orientation, right, we know that we have a tensile load of P over A, but we don't know what is it yet. We only know it's P over A, but we know the area, by the way. Okay. Okay, P over A. All right, this is also P over A. So this is our like point X on Mohr circle. This is point Y on Mohr Circle